Afternoon, guys. I'm Dave Canterbury with Self-Reliance Outfitters in the Pathfinder School. And what I thought I would do today is I want to just disseminate or pass on some information to you guys. A couple little tricks that I figured out and learned as well about these handheld radios. We talked a little bit about communication and why radio in one of my recent videos. We talked about this little Bofang UV5R as a great starter radio. And I actually made my first contact with this simple buggy whip antenna the other day from a wildlife area. I wasn't really on real high ground, but I was able to hit the repeater here in Jackson. And I talked to a guy in Portsmouth, Ohio.
There today, I'll be honest with you, I haven't done a whole lot of anything here. I've pretty well stayed in the house the biggest part of the whole day there. I was out for a while, but my goodness, it was just too warm for this old man, so I come back in the house.
Well, I appreciate the contact, buddy. Like I said, it's my first one, and I really appreciate it. You're coming in loud and clear, being all the way over in Portsmouth through this repeater. Yeah, it's been very hot outside, but I'm thinking that once it cools down, fish might start hitting top water for about 20 minutes, and that's about 56 miles away. So with that said, you know, a lot of what has to do with how well you can reach that repeater is the antenna itself. The radio needs to be a decent radio, obviously, but the antenna is the kind of the meat and potatoes of the whole thing. And I don't think a lot of people realize that. I know I didn't realize it when I first started looking into this whole radio thing. What I want to talk to you about was, we talked in that first video about how to improve on this Bofang's distance by putting a portable survival antenna up in a tree. And a couple things I want to show you today. Number one is I want to show you how to make an improvement to this radio itself with the antenna on it that will give it a little bit better capability. And then I want to talk to you about a system I've made for my antenna, my survival antenna, for a traveling base unit type antenna if I'm camped somewhere and I don't necessarily have trees. Having a rooftop tent, I don't have to have trees. Having a rack on the back of my Jeep that will hold a hammock, I don't have to have trees. So I'm not restricted to those type camp areas anymore. And I can camp in an open area like I'm in now and not worry too much about it. However, if I want to get that antenna up in the air, I've got to have some type of pole for that or some type of mast to get that antenna up in the air. I'm going to show you that today as well. So stay with me, guys. We're going to get started. Okay, so I don't want to get real complicated with the explanation of how antennas work and antenna theory. There's plenty of videos out there with way more knowledge than I have on the subject. I'm trying to pass on things that I'm learning as I'm learning them to kind of disseminate this information to people who might be new to radio or on the fence and think it's too complicated for them, because it's really not rocket science. It's very much like survival. Once you understand a few basic concepts, it becomes fairly simple. And one of the easiest antennas that you can fashion from scrap material or something you may have around the house, or even build yourself by ordering components, is a dipole antenna. And a dipole antenna is basically an antenna that's built from two quarter wavelength pieces of conductive material. So rebar, wire, barbed wire fence, anything that you could cut to length would work for a dipole antenna. And what you would do is you connect your coax cable to that with the wire to one side and the shield to the other side. And that would give you that half wavelength dipole antenna, whether it was oriented vertically or horizontally, again, depending on what you're doing. Most of the time with something like 2 meter, you're probably better off with using something that is oriented in the vertical. And if you look at a rubber duck antenna, that's basically what you're doing, is you have a vertically oriented antenna on that rubber duck. The antenna that we're using, the survival antenna, the J-pole antenna, which is very similar to a dipole, is also vertically oriented antenna. When you get into other antennas for lower frequencies in the HF band, you're going to want to go more with horizontally oriented antennas, and we'll talk about that more in future videos. But the important thing to understand is, A, how do antennas work? And antennas, what they do is, your radio, when you push the talk button, your radio is pushing an alternating current. So when the current goes into those two halves of your half wavelength antenna, they're going like this, back and forth, positive to negative. All right, so they're doing this. And as they're doing that, they are creating that wave, that electromagnetic field that becomes your radio wave. That's pretty much the simple explanation. I'm going to put a little graphic up here for you that's like a GIF that will play, and it will show you kind of how that works, positive, negative, and how that waveform runs through there, and it'll give you a better idea. But as far as dipole antennas go, think back to when you were a kid, if you're my age or older, when you had rabbit ear antennas on your television set. That was basically a dipole antenna. You had two pieces of material that were adjustable in length and could be adjusted this direction to get better directionality for the signal that you were trying to chase down for your television. And it was connected into the back of your television, one on each side, or by coax cable, so that you could receive a signal into your television. It's very much the same with a dipole antenna on a radio that you're going to build. So what you would do is you would figure out what the length of those components needs to be, because they have to be a certain length to create the field they need to create for the frequency that you want to operate on. So when you look at an antenna on like something like this handheld Baofeng, what this is pretty much half of an antenna, and you become the other half as you are pushing the talk button. You have the radio in your hand, you become the other half of that antenna. The problem with that is it's not very balanced as far as the length goes. And the important part of a dipole antenna really is that the lengths of those 2/4 wavelengths are equal, so that they create an exact half wave for the frequency that you want to operate on. So there are things that we can do to improve this. And to improve on this, what we do is we put what's called a counterpoise or a tiger tail on the radio. What that means is we're going to take and create the other half of this dipole style antenna by putting another wire coming out from that antenna on what would seem to be the negative side. Again, it's going to be positive, negative, but basically you've got a negative and a positive side that you're attaching to. So your negative would be something connected to the chassis of this radio, like the screws that go into the back of it, or the bottom area of this recessed part where the antenna goes in. However, you can't get anything down in there very well because it is recessed. So what I've done is I've taken a piece of cable from a bicycle brake line that's got that nub on the end of it, and I've left that nub on there so it doesn't poke me or anything. And I've cut it to length and then just soldered a connection on there and shrink wrapped it so that I can screw that counterpoise or tiger tail right onto the back of my radio underneath that chassis screw right there. And now I have created that half wave dipole antenna, and I can use this to increase the efficiency of this radio. You can also take this and you can directionalize it a little bit to get those waves to travel where you want them to for reception or transmission. Now, I have just made these about equal length because they will resonate better that way. However, they may not be resonating on exactly the frequency I want them to. And from my understanding, when you tune an antenna, it's going to be tuned to one exact frequency. And it may transmit and receive on others within that band, but it's really only going to be resonant on the one frequency. So to figure that out and figure out those links, you have to do some math to figure out what you want to do and how you want to build it. We'll talk about that in just a minute. Okay, so with all of that being said, now let's talk about for a minute, just real quick, about antennas so that we understand why this is an important survival piece of knowledge. Because if I have a radio and I have a way to connect coax cable to that radio, and we can do that with that adapter that I showed you in my first video on my Baofeng, is very easy to do. Or we could have a bigger radio, like a base unit radio that we carry in a backpack, and it would have a coax connector on the back, and then we just need to build an antenna. You may not want to carry all the pieces and parts that you have to have for an antenna, but there's ways to carry antennas in a very small package as well. We're going to talk about later, because like I said, you can use any ferrous material, including just a roll of wire for an antenna. The important part is understanding the length that you need to make those wires and the configuration of those wires to talk and listen on the frequencies that you want to hear. So, staying away from a whole lot of complicated math. Understand that the standard formula to figure out a dipole antenna length, and this is your basically a quarter wave, because what you're looking at is a full wavelength is X. A half a wavelength is generally considered 468 is your denominator, common denominator is 468. 468, is that right? 2, 3, 4. Yes, 468. And the easy math on this to remember in your head, easy formula that I was taught by one of my Elmers that I'm using in this ham club that I'm dealing with down in Kentucky is 1, 2, 3, 4. What that means is one side of that dipole is 234 divided by the frequency you want to talk on it. 234 is half of 468. 468 would give you the entire length. 234 would give you half of that, or 1/4 of that wavelength. So if you put two of those quarters together, you have a half wavelength. So one is positively charged, one is negatively charged on the coax. That's the simple answer, okay, without getting too complicated. So all we need to do is know what frequency we want to talk on or transmit on, and then build an antenna to receive and transmit on that frequency. And you can go backwards on that to figure out what frequency your antenna is set up on your radio that you buy to transmit the best on. And then you can either trim that antenna if it's too long, or get a different one if it's too short. So let's talk about that real quick. Okay, 144.200 or 144.200 megahertz is the national call frequency for 2 meters on ham radio. So if we want to stay in that range, we probably want to go a little bit longer, but we definitely don't want to go much shorter than that, okay? Because we want to stay within that 2 meter band. So all we need to do is take our calculator and go 234 divided by 144.2, and that gives us 1.6 feet. So if we times that by 12 inches, that tells us that 19.4 inches is our optimum length. So if we go with about 19 and a half inches, 19.47, so if we go 19 and a half inches, that's going to give us a pretty good measure of where we need to be to get into this frequency for transmitting and receiving. If we wanted to go a little bit longer than that, we could, and then we could just dial it back as we needed to. It's always better to go long first because you can't add more after you cut it off. But 19 and a half inches is pretty common for a 2 meter dipole antenna. So if we're going to build an antenna, we want 2 pieces of wire or 2 pieces of conductive material 19 and a half inches long. Okay, so understanding the math on how we build these antennas, or how long our component parts have to be, whether they're a piece of wire, a piece of rebar, a piece of barbed wire fence, any conductive material, again, like we said before. Now we have to look at, if we're going to transmit on HF bands, on those lower frequencies, then those components are going to exponentially grow in length. And just to give you a quick example, I did some math last night for the 20 meter frequencies. When I get to the point where I get my general license next month and I can transmit and receive on those frequencies, then I'm going to want to build a dipole antenna that I can carry with me. That's mobile. That's the whole key to this with me, is the mobility part of it. And just carry the power supply and the transceiver and be able to makeshift put up an antenna as quickly as I can. Now, it's the same thing. We need to use 2 pieces to make a half wave, and then we're going to make it horizontal in orientation and get it up off the ground a half wave and have it a half wave in total length. That's the key to that. But as I said, I did some math last night, and for 20 meters, you're talking about, if I remember right, about 16 feet per quarter wave. So that means 16 feet of wire, if that's what you're going to use on one side, 16 feet of wire on the other side, all of that hoisted up 32 feet into the air to be able to transmit and receive on a mobile radio on that 20 meter band. Okay. Now, there are things that you can use to make things very mobile. This is a very simple centerpiece for a makeshift antenna. It has 2 connectors on it where you can connect your wire that's running off to the sides, and it has a coax on the bottom where you can connect it into your radio. And then it has several different points on it where you can hoist it into the air, and where wires can go through and come out, and then have insulators on the other end to be tied up, insulator on this end be tied up, hoisted up 32 feet in the air. But when I'm done, I can pull that down, wrap it onto some kind of a spool of some sort, and pack it down into a fairly small package, and have an antenna that's capable of transmitting way longer distances, because at that point, repeaters aren't involved. I don't have to worry about hitting the repeater. I'm worried about sending waves out and over and getting long distance communications with this. Again, this is down the road for me, but I'm preparing ahead of time, and I'm taking my test on the 14th of September, so I plan to have my license within the next month. I wanted to go over a few of these things with you today, and I want to talk to you about this other antenna real quick, and I want to do some testing of that antenna while we're out here, so stay with me. Okay, so let's talk about what we're carrying for this mast project. We've got a couple connectors here for 3/4 inch Schedule 20 PVC. I've got one end cap that I have, I got one end cap here. I have one end cap that I drilled a hole in. The cord is going to go through that hole to bring that antenna to the top and then tie it off in a stop knot. I've got multiple connectors here. I'm probably only going to need one of these, maybe two, that are just connect two pieces together. And then I've got one piece that's a T, and this is where my coax cable is going to exit so that it comes into my radio and it's not going down into where my mast is going to be based into the ground. And what I'm going to use for that is I've got a piece of 3-foot conduit that's 1 inch, and it's cut off at a 45. And this 3/4 inch PVC will slide straight down into it, just like this, to form a base. So all I have to do is pound this in the ground, and I'm ready to start assembling the antenna. Okay, that should be deep. Okay, we're going to take our T, and we're going to put it in the side and come up through just like this. We're going to pull our antenna, which is the same antenna we had the other day, this one here, and we're going to feed it through just like this, okay? And we're going to pull that all the way through, just continuous feed it, just like that. And we're going to feed that right up to the coax cable. You don't want a bunch of twists and turns in this coax cable either. You want to get them all out and get it straight as you can get it. And we're going to stop right where the connection's at, okay? This is going to be our upside. So now we're going to take this string and we're going to take about a 4.5, 5 foot section of that PVC, and we're going to feed the string right down through it, just like this. Pretty quick and easy. Once we get it through there, we'll pull the antenna up through it. And this should get us pretty close. If you can see, right there is our connection point. And we still haven't pulled the top of the antenna out of the PVC yet, but we're close looking down in there. So now we're going to take our end cap and we're going to feed our line through the end cap just like this and pull that section of PVC up to us here, drop the end cap on, pull that up tight, and we're just going to put a stop knot in there. It's not going to pull out, just like that. And that's going to hold this antenna where we want it and allow the feed line to come out. And now we can just throw that paracord off to the side. We don't need that. Then depending on how high we want to put this antenna, we can just snap another section in and we can drop it in the base and see where we're at, just like this. And we're about, I don't know, 8 or 9 feet high right there. If you look up, we're about 8 or 9 feet up there, something like that. And now we can either put another piece of PVC in there to get it up a little higher, or we can experiment with that and see what that buys us. And then all we have to do is take this coax, plug it into our radio, and we're ready to go again. Okay, we've got our pigtail on our radio, and we're just going to plug our coax into that, screw that bad boy down, turn our radio on.
Channel mode.
Ready to transmit. Kilo Echo 8 Sierra Papa Sierra. Hey, thanks for calling me back, buddy. You in Jackson?
QSL, can I help you, sir? This is WB8 Lima Delta Bravo. Name is Bob. Actually, about 5 miles northwest of Jackson, in the woods. But yes, I am Jackson area.
Okay, I'm just setting up an experimental antenna with a PVC mast. I'm out here in Cooper Hollow Wildlife Area, just looking for a radio check.
You're loud and clear from what I can tell. Once you hit full quiet, you can't do much more. That's pretty good considering the repeater itself was actually up my way. So you're probably about 15 miles from the repeater site.
Roger, Roger. Thanks for the information, and I appreciate the check. Kilo Echo 8 Sierra Papa Sierra, out.
Kilo Echo 8 to Sierra Papa Sierra, WB8 Lima Delta Bravo, Jackson.
Okay, there you have it, guys. Just a quick radio check. Again, he said the repeater is about 15 miles away from me, and he is on the other side of Jackson somewhere. So we're getting probably 20 plus miles of coverage easy enough, like it's nothing, with this simple makeshift antenna mast. An antenna, again, the antenna that's in the mast is what's important, not necessarily the radio or the mast itself, just getting that antenna in the air, and this is a simple way to do that. Okay, well, I didn't keep all of that filming while I was talking to this guy, but I actually went back to the wire antenna off of the makeshift aerial that we have here, and the signal got completely trashy. The guy couldn't hardly even hear me because I'm not on high ground at all right here. So I switched it back, put the coax adapter back on there, and went back to the J-pole antenna here, back with his mast, and he heard me perfect again. So that's just case in point of how much difference an antenna can make and how well you can talk over distance with something as simple as this Baofeng. Okay, guys, I'm going to get this equipment tore down, and I'm going to get out of here. Just wanted to shoot a quick video for you guys today, discussing a couple little quick improvements you can make to these cheaper Baofeng radios that will get you more distance, might make you a little bit more mobile, and things that you can carry around for emergency use or base camp use if you wanted to. Like I said, that antenna can be jacked up into a tree like on my last video, or we can makeshift a mast for it like we did on this video. And you can also add things to the Baofeng radio like that tiger tail we put on there to make it a little bit more effective. But again, you know, my contact today, 15, 20 miles away-ish, something like that probably, from where I'm at, said that J-pole antenna with the mast was spot on. And I'm kind of in a valley here in this wildlife area. So that's really, really good. I appreciate your views. I appreciate your support. I thank you for everything you do for our school, for our family, for our business, all of our sponsors, instructors, affiliates, and friends. I'll be back with another video in this series on radios. As I learn, I'll be disseminating that knowledge on to you. So if you got any questions or comments, please leave them in the comments below. Any hams that are on here, got any suggestions, please leave them in the comment section below as well. I appreciate everything you guys do for me. Thanks.